This video is about using addition and subtraction properties to solve 2 or 3-step proofs, and use multiplication and division properties to solve 2 or 3-step proofs. So in the addition properties, we have if a segment or angle is added to congruent segments or angles, the sums are congruent. And if congruent segments or angles are added to congruent segments or angles, their sums are congruent. So in this case, we either have one part being added to already congruent segments or angles, or two parts that are congruent added to two other parts that are congruent. In the subtraction property, we have if a segment or angle is subtracted from congruent segments or angles, then their differences are congruent. And if congruent segments or angles are subtracted from congruent segments or angles, then their differences are congruent. So between these two operations, we need to remember that if we are proving something is larger than the original givens, we are going to be using addition. And if we are proving something smaller than the original givens, we are going to be using subtraction. The other two operations are multiplication and division. So in multiplication, if segments are congruent, then their multiples are congruent. If angles are congruent, then their multiples are congruent. In the division property, if segments are congruent, then their divisions are congruent, and if angles are congruent, then their divisions are congruent. To know when we're using multiplication or division, we want to look for words like midpoint, bisector, or trisector. When we're trying to prove something is larger than our givens, we use multiplication. When we're trying to prove something is smaller than our givens, we use the division property. So in number 1, we are given that angle NOP, so this whole angle, is congruent to NPO, this whole angle. We also know that ROP is congruent to RPO. We want to prove that the other two angles are congruent. We could do that because we know the whole angles are congruent. We can subtract out the littler angles that are congruent, so those angles would be congruent by angle subtraction. In number 2, we are given that R is the midpoint of NS. So remember, a midpoint bisects a segment into two congruent parts. We also know that O is the midpoint of MP. So this is bisected into two congruent parts. And MO is congruent to RS. So if MO is congruent to RS, we know these are congruent. And because O is a midpoint, we now know all four pieces are congruent, which means we now know that this whole segment is congruent to this whole segment. And because we have one of our vocab words, midpoint, this is going to be segment multiplication. In number 3, angle TRY is congruent to angle ABE. RW trisects angle TRY, so if these are trisected, they're congruent. BC and BD trisect, so if those angles are congruent, they are also now all congruent, the little pieces, so we know that these smaller angles are now congruent by using angle division. In number 4, we are given that AB is congruent to EF and BC is congruent to DE. So we have two congruent parts that are added together. So we now know our entire segment is congruent. So this would be segment addition. In number 5, we know that RT is congruent to SV. We want to prove that RS is congruent to TV. So if we cut out this middle part, ST, from both segments, the remaining also has to be congruent. So this would be segment subtraction. In number 6, we know that SN, or SA, is congruent to WN. We also know that SW is 3x plus 5, AN is 6x minus 7, and WA is 12. So because WA is the shared part of the segment, if we cut that out, we know that these two smaller pieces are congruent by segment subtraction. So we would have 3x plus 5 equals 6x minus 7. So we get 12 equals 3x. We divide, x is 4. Then we want to find WN. So WN is going to be 12 plus 6 times 4 minus 7, which gets us 29.